Welcome to the second week demonstration lab. So this week we're going to continue with the general social survey, which again is a data set representative of all US adults. And we're going to look at one particular variable, and we will open up SPSS and start using it. So we'll look at some descriptive statistics, especially breaking it up into quartiles. And we'll also break it down by another variable to see how views on this variable differ by something else. So the first thing it says is to open up the files you need. So this is the same data set that you opened up for the demo lab last week to take the screenshot. So same thing is that if you're at the textbook, and you go to the appendix, you'll see right under data sets, here's the AINS one, that's what you're going to use for independent lab. Here's the GSS one. So you'll download and open this data set, and you'll open this code book. So you didn't look at that last week, but you'll open both those files. And then on Blackboard, there's one more file that was attached with this, which is a syntax file. So here on Blackboard under week 2, right, this is where this file came from, the Word document, and then the .sps, this is the syntax file. So you'll open all three of those. So let's see what those are first. So the data set you saw last week, and we'll look at that again in a moment. Now the code book for GSS basically tells you information about all of the variables. So you can see here, this is how many cases there are total. We'll talk about weighting later. And here's a list. You can click on these to just jump to the variable that it is. And these are all of the variables in the data set. So for example, TV hours, the variable name is TV hours. It's hours per day watching TV. So people were asked on the average day about how many hours do you personally watch television? And they can answer anything from 0 to 24, which is the number of hours. Or like this one, for example, work stat is their labor force status. And so this was what were you doing last week? And the number corresponds with this. So like if somebody has a 5 in the data set, then that means they're retired. Okay. And then the syntax is programming language. So let me open that up. Okay, and so when we get to running things, this is the programming language. And so I already have this for you. The stuff here in gray with the asterisks and the periods is just notes. And then this is the stuff that you're going to run and change parts of to name, like what variable we're using, etc. And so we'll look at that in a little bit as well. And if you ever have trouble when you try and open a data set just by like double clicking on it or whatever else, the kind of more foolproof way to open a data set is once you have SPSS open to go File, Open Data. And oh, it's 2022. Yeah. Okay. Anyway, so I'm opening my data set. And here it is. Okay. And when I opened that, it also opened this, which just shows me the syntax that said, oh, you opened this data set, right? You got this from this place in your computer. Okay, so we opened up the files that I needed. Just gonna erase that. So next it says the General Social Survey contains data on about 3,500 US adults based on a nationally representative cross-sectional interview and survey. What is the unit of analysis for this data set? How do you know? So remember, the unit of analysis is what you are analyzing. It's what each case represents. So if I'm looking at this, these are my different variables like age, hours worked last week, gender. If I'm looking at the data view, each row is a case, and it's saying, what is each of these rows represent, right? What is this of? And so, right, what do I have in this case? Just over 3,500 cases of, right? Like, and so for this case, for example, we know there's an age of 72, a class of 3, we'd have to look at the code book to see what they mean, right? A family income in 2021 of $100,000, right? They don't own a gun, etc. So what is this case? Each of these cases, what are they? They're individuals, right? And so the unit of analysis for this data set is the individual, right? Or it's a US adult. It's at the individual level. Each case represents an individual. Each variable has data for each individual. And so that's what it is, right? So you could have a different data set where each of these rows is a state, right? Or each of these rows is a movie, right? And so for this one, each of these rows is an individual. That's what this data was collected, and it wasn't transformed. It wasn't collapsed on any level or anything like that. It's just an individual level data set. Now we're going to take a look at the variable theism. So I could look at it here, right? Here's theism, and here's a label for it, and here's some values in terms of the coding. But this is both harder to look at and less reliable and doesn't always have the information that we want completely. What I want to do instead is to use the code book. And so if I have the code book here, I'm going to find the theism variable. I'm doing search and find. And well, I can click or I could search for it there. And here's the variable theism. So it says, what is the survey question? Okay, and so this was the survey question. This came from the GSS. The original variable in GSS was named God. I renamed it here theism. But the survey question was, which statement comes closest to expressing what you believe about God? Okay, what is the variable's level of measurement? How do you know? So it could be nominal, ordinal, right? It could be interval, but we're more thinking about ratio here, or it could be one of those dichotomous variables, an indicator of just 0 and 1. Okay, so let's see what it is. So we can see this is coded from 1 through 6, right? It's not 0, 1, it's not dichotomous, there aren't only 2. Now nominal would be if these are categories or names. So like if this was and these definitely are different kind of beliefs, right? Like, how do you believe about God? So maybe it is. Let's see if it's nominal or ordinal, right? So ordinal would mean these are ordered. So as we go from 1 through 6, we're going from I don't believe in God to I believe in a higher power to I feel there probably is to God exists. So as we go up, theism increases, right? The belief in God increases. People are more sure that they believe in God. And as it goes down, right, people are less believing. So this is ordinal because it's ordered, right? If these were not in order, right, if it went, I don't believe in God, I do believe in God, I'm not sure, whatever else, that would not be ordinal. They have to be ordered categories for it. So it's not nominal because while they are named categories, they're actually in an order. Something like race or favorite color would be nominal. And then is it ratio? So for ratio, these would need to be actual numbers that have that mathematical meaning, where 0 would be like the absence of belief in God. 4 would be double belief of 2. I don't know, it would be like something like if we had income in dollars or hours worked or something like that. And this isn't that. And so this one is ordinal. Okay, so the variable is ordinal. I know this because it is ordered categories. The answers are qualitative, right? They're like named answers about belief in God. And they are in order as they go from those who don't believe to those who believe, to those who fully believe. Okay, so we can see how as the coding goes up from 1 through 6, right, belief in God is increasing. Okay. So is the variable appropriate for generating a median and 5-point summary? So if it was nominal, we couldn't do a median, right? Because there's no middle, the middle doesn't mean anything, right? Like if you had favorite color, you had blue and yellow and green, even if we assign those numbers, it wouldn't mean anything at that point. But this thing, can we split this up into quarters? So say like a quarter of respondents are between here and here, a quarter are between here and here, a quarter between here and here, etc. And so at the ordinal level, and we could even say this is like almost ratio-like in some ways, because we can do this, right? We can split this up. Again, I'm saying it's ratio-like because it's not ratio, right? Like these numbers aren't exact. The difference between a 2 and a 3 and a 3 and a 4 are not identical. But we might end up saying, oh, a quarter of them are between, or like if the median, let's say, was 3.5, right? That's not an actual meaning, but we can say, oh, that's somebody who's somewhere between believing in a higher power and sometimes believing in God. So like we can get a kind of general sense of it. So let's say yes, it is ordinal and and split the data up into quarters. Okay. So now it's time for SPSS. So there's a couple things to do here. I'll show you this both with dropdown and with syntax. And so the first thing we want to do is just make sure that our output's going to display our syntax commands in the log. So that means that when we do something, the syntax will pop up in the output telling us what we did. So there's two ways to that. I can go to edit, options, and then I can go to viewer and make sure this is checked, display commands in the log. If it's not checked, check it and click OK. Or on this syntax, I have this line that's going to do it, set print back equals on. And so I'm just anywhere on this row. So I clicked onto the text on this row, and I'm clicking this play button, and that'll run it. And so you can see set print back equals on runs. And I'm going to just copy and paste that. I could do that from my output. I could do that from right here. Doesn't matter. And I'm going to put that here just because I'm keeping a record of what I did. So what this means is that when I run something, like let's say I were to run a frequency table of age in 3 categories, you can see that beyond giving me this frequency table, right, it gives me this syntax that says, here's what you did, right? This is the programming language that generated this. And so that just makes sure it is. It used to be the default in earlier versions of SPSS. Now it's not the default. And so you just want to turn it on so that it stays on and so that you have that syntax to keep track of what you're doing. Okay, then it says turn on weighting. So we're going to discuss weighting later, but for now, you just need to use the weight variable, and you're not going to use theism. You're not going to use any other variable other than the weight variable designed for it. So this is going to adjust our output to more closely represent all US adults, because when you sample, right, and you do your best, but inevitably some people do respond, some people don't respond. You might end up having more women respond. You might end up having other things like if it's a household-based, I know GSS used to use this household-based mechanism, and so people had a higher chance of being selected if they were in a smaller versus bigger household. But this just adjusts it to our population-based characteristics to make it more accurately reflect our population. So for this, you have two options. You can go data, weight cases, and we need to choose our weight variable. So let's go back to this code book. If you look at the code book, you'll see here's weight variable. The name of the weight variable is weight variable. In actual GSS, it was WTSS-NRPS, but I made it simpler here. And so we're going to weight by what's named the weight variable. So you don't want to use any other variables, because basically this is going to multiply each case by the weight. And so, for example, if you used age, right, it would multiply somebody who is 70 years old would count 70 times. Or for theism, right, it would do somebody who's at a 3 would count 3 times, and someone who's at a 6 would count 6 times. And so this would skew the data where folks, I guess, with more belief would count more as multiple people, basically, compared to folks with less belief. You can see in here, you don't want your weights to be too humongous, but you can see, right, that they are going from like 0.13 to, so here's a big one, but most of them are like between like 0.5 and 2, 1.2. And so again, that's saying like this case is going to count as a little bit more than one case. It's going to count as about 2/3 of a case, right? And that way it's just going to adjust it so that it better mirrors our actual US population. So that, because we don't really care about this sample per se, right? We don't, these random 3,544 adults, we care about US adults as a whole. And so we want our sample to better reflect them if possible. Okay, so here, if I go here, I'm going to say weight cases by. So I'm going to click to weight on. If I want to turn weighting off, I would just go back to do not weight cases and click OK. But I'm weight cases on. I'm going to find my weight variable. I can see it's right here. There's different ways to sort this. So I can right click and sort it alphabetically. I can change it to just show the variable names instead of labels. File order would be the order in the actual data set. So here's my data set. So like that would be this order. And once you have them like this, like I have them sorted alphabetically, if I click W, it'll bounce me down to W. Or if I was here and I click P, it'll bounce me down to the P. So anyway, I'm finding the weight variable. When I double clicked and it went in, or you can click it once and click this arrow and click OK. But again, the really important thing here is that when you turn weighting on, you're using weight variable and you're not using other variables for weighting. Okay, so I did that. I'm gonna add my syntax here. If I'm using syntax, again, you don't have to do it both ways, right? I'm showing you that, but it's just duplicative, right? And so when you do it one way, it does the same thing. When I do the dropdown, you can see it generated the syntax, the programming language of what to do, which is the same as this. So it basically is telling it what I'm telling it to do here. So this said weight variable name. So I need to find the weight variable name, which again was weight variable. And so here it is, the line. I just changed again this from weight variable name to the actual name of the weight variable, which was weight variable. That's what it said. I can just type it in directly from what it said in my code book. So again, I found the weight variable. So I put it at the top because we're using it there. So this is the name of it. So I just typed that in. Make sure that when you type this in, you leave this period, which tells us the command's over. Without that, it won't work. So you just want to change the variable name here. You don't want to change anything else there or else it won't work correctly. And now I'm on this line, I'm clicking play, run selection. And again, it's just waiting it. There's no outputs of any data analysis here because it's just telling it that when you run analysis, we want to weight it so it better matches the target population. Okay, so next, it says, now generate a 5-point summary, range, interquartile range, and box plot for theism. You can either generate the interquartile range using SPSS, or I can generate my quartiles and then write the equation. So I could do the third minus the first quartile, right? The upper verse minus the lower quartile. And it says, okay, so weighting's on. So a couple ways to do this. If we look at here, this one, I'm going to change the variable name to the variable I'm interested in, which is theism. And I can click run. Oop. Okay, that gave me an error. It looks like I mistakenly posted the name of this file here. Sorry. I'll make sure that you have the right one. That should just be a 95 on this line. Anyway, so I type this in, and anywhere you see this command is from here to here. So I can click anywhere within this space, and I'm going to click run selection. And you can see it generates a bunch of stuff. And then, and that gives me the interquartile range, gives me the minimum, the maximum, the range, the median. Here's my Q1 and Q3 and Q2 again. Here's a box plot. Another option is this one, which if I put it in, you can see gives me the median, the range, the minimum, the maximum, my Q1, Q3, median, or Q2. So this is simpler to look at than this per se, but it's missing the interquartile range, so I'd have to do this minus that to get it. And then that one also didn't give me a box plot. This one just gives you the box plot. So you could run this one, you could run these two, you could run all of them, it doesn't really matter. So here's my box plot. The other option is to use drop-down menus. So for drop-down menus, there's a little bit more we have to do here. And you can look back at the chapters if you want kind of the guide to see where to click, but I'm gonna do first, let's try analyze descriptive statistics frequencies. And so here I'm gonna put theism in here. And I need to tell it what statistics do I want. So I'm clicking on that statistics button and this new window pops up. I want quartiles, I want the median, I want my minimum, I want my maximum, I want my range. And I clicked on charts. I also want I don't want any of these actually for this one. So that's good. Later we'll do histograms and stuff. You could do a frequency table. You're not going to want to do that for your independent lab because your variable there goes from 0 to 100. So I could uncheck that if I don't want it. I'll just keep it on. And so you can see that generates then both my syntax right here of what I did, as well as here's here's my frequency table, but here's the statistics. I could do explore. And I could again put theism in. And I have to choose statistics that I want. So here I want my quartiles under percentiles. And let's see what else. I don't think options. And then I also want to have I don't need any of those actually added. Stem and leaf plot, let's turn that off. But anyway, if you have both, it'll give you graphs and tables with summary statistics. If I just set this, it would only give me the summary statistics. If I just set this, it would only give me the graphs and figures. I do want that box plot, so I'm going to keep it on for both. And so again, that gives me all of this. So those all give me lots of stuff. I'm going to stick with the first one I did because it just had everything I needed in the one. And so I'm going to copy this syntax over. And then it says to also copy my output over. So I need, sometimes you can copy this and like as a image. I'm going to take a screenshot of it. And then, did it say to do a box plot yet? Yeah, it did. Okay, so let's grab my box plot too. Where'd box plot go? Right there. Okay. That will up. Okay. So now it says, look at your box plot. Are there any outliers? If so, where and what does this mean? If not, what does this mean? So if there were outliers, there'd be little dots or asterisks here at the top or bottom, and there are not. So there are no outliers. And that means there's no cases that are kind of extremely different than where the rest of the cases are. So again, the way that for a box plot, the way outliers would work is that you'd have to look at like if this is the middle 50%, it'd have to go like beyond that in both ways out from here and from here. And we can see there's none that are like that far apart to be extreme values. And this makes sense because we only have going from people who don't believe in God to people who fully do believe in God, and there's plenty of people in all of those categories. There is no one with an extreme view on God that is markedly different from where most of our respondents are. That's what that means. Let me just try another example and see. Let's see, like for age, for example, whether there's any. I'll do a couple. I bet one of them will get it. So let's do age. I'll do hours worked last week and physical health. So when I look at these, you can see no outliers here. here you can see outliers. Now I like to get rid of these numbers on them because these are the case numbers, like the which doesn't really tell me much of anything. And so it's easier to look at without those. I mean, they tell me what case number it is if I wanted to go and look it up in the data set. But it's saying like number of hours worked per week. So here's where most folks are, but there were some cases that were more extreme. They were further apart from where kind of everybody else was. And so this one would say there were some outliers, right, of people who worked very few hours compared to the rest, and some who worked a lot of hours compared to, right, most people who were between like 20 and 60 some hours. Here we can see days of poor physical health, that, right, the outliers are just among the higher numbers, right? So, right, most people were between 0 and 5 days of poor physical health, but there were some folks who had more days of poor physical health, and that was not kind of the typical, right? That doesn't fall into where, if we look at where this middle 50% is, you have to go out further to get to kind of that space from the upper quartile. Okay, so now it says to interpret the following statistics in their real life context and tell their story. So first, I just want to get these statistics and write them down before I interpret them. So Q0 is my minimum. That's right, the one that's bigger than 0 quartiles of the data. And so here's my minimum, which is a 1. Q1 is my lower quartile. That's this 25th percentile, so that's a 3. Q2 is my median. That's 5, or it's the 50th percentile, that's 5. Q3 is my upper quartile, 75th percentile, that's the 6. Q4 is my maximum, that's 6. My range is Q4 minus Q0, that's 5. Right, we can see that's the 6 minus 1. So it went from 1 through 6. And my interquartile range is 3. And if I didn't have that, I could do Q3 minus Q1, which is, right, 6 minus 3. So this goes from 3 through 6. If I was using one of these other outputs, again, it'll be a little different. So, for example, this one right here is Q0, Q4, Q1, Q2, Q3. Here's my range. Here's my Q2. And then I have to do Q3 minus Q1 to get my interquartile range. Okay, so now I need to interpret these. And to do that, I'm going to use the templates that are in the textbook. So let's start with, I think there's a median one, the median one. And here's an example, but I'm going to copy this. And so this is Q2. And so I'm just going to fill in the blanks for this. So the median means that half of cases had, right, 5 or fewer. And then half of the cases had 5 or more. Okay. Now this is still really confusing, and so I need to go back to my code book. So what this means, let me find my code book. And let's go back to theism. Okay, so actually, no, I'm gonna put in, so I don't need to keep going back to this. I'm just gonna copy this. Right here, so I just have it. But let's put it on the 2 screens for now for this. Okay, so what this is saying is that half of the cases were here or lower, and half of, sorry, we were at a 5. Sorry, we're here or lower, and half of the cases were here or higher. And in fact, we can see that if we look at this frequency table, right, that half the cases, so we had some cases here, like 4.5%, almost 5%, etc. And so by the time we get here, half of them were here or lower, and half of them were here or higher. So what does that mean in context? It means that, right, half of our respondents, right, half of the US adults who took the survey, what does it mean to have a 5 or fewer label? It means that they either had doubts, but felt they believe in God. So they were somewhere between that and here, right? They're that or less. So half of respondents were somewhere between atheism, so not believing in God, and having doubts but feeling they believe in God. So that's what it means to be 5 or fewer in this, right? It's like 5 to 1, right? 5 or less. We don't know where they are just from the Q2 equaling 5, but we know it can be anywhere from 5 lower. And then we know the other half of respondents were at 5 or higher. And so half of respondents either had doubts but felt they believed in God, or definitely believed in God, right? Because they could be at a 5 or a 6, right? They're 5 or higher. Okay. Now let's look at the next one. The easiest ones are probably Q0 and Q4. So for this one, we're saying the lowest or least label is 1. And so that means that, right, the lowest is not believing in God. So at least one person was down here. So that means basically that at least one respondent does not believe in God, or reported not believing in God, right? We have at least one that's at a 1, which is the lowest code that we have. And then if we go to Q4, the maximum, which is a 6, right? It's the highest one here. We know that at least one respondent definitely believes in God, right? So like if our minimum had been here, then we would have said there's no respondent who don't believe in God. Everyone at least is agnostic. Or if our maximum was here, we'd say there was nobody who was like had no doubts about it, right? But it went from 1 through 6. Okay, so now let's look at our quartiles. So what's the range? Back to that. Okay, lower quartile and upper quartile. So the first one, the lower quartile, we're going to say 25% or a quarter of respondents were at 3 or lower. And that means that 75% or 3/4 were at 3 or higher. Okay, going back to what that actually looks like, again, we're saying that the first quarter of respondents are somewhere in this range. And so a quarter of respondents were somewhere between atheism, which was that 1, right? That's our minimum, and believing in a higher power, but not a personal God. And then the other 3/4 were at a 3 or higher, meaning they were between believing in a higher power, but not a personal God, and definitely believing in God. Okay, so that's, if we look at this, right, so far we've looked at our median, we looked at the minimum, the maximum, now we're looking at this. So we're saying that a quarter of folks were here, right, between 1 and 3, and 3/4 of folks were between 3 and 6. Okay, and then this is, for Q3, it's kind of the opposite. So, right, so this is bigger than 3/4 of the data, right? So 75% or 3/4 of respondents were at 6 or fewer, and then 25%, 1/4 of respondents were at 6 or higher. So what does that mean in context, right? What is that actual the story about it? So if we go back to the code book again, 6 or lower doesn't really tell us anything, right? It's the whole range. So we know that a quarter of respondents were 6 or higher. They can't go higher. So we know that at least 1/4 of respondents definitely believe in God, right? They don't have any doubts about it. And the other 3/4 are somewhere between atheism and doubtless belief. But again, we don't know where they are from that. So really, I mean, I could leave this sentence off. It doesn't give me that much information, but this is what this is telling me. And so that's saying again that the third quartile is here, right? So it's actually the same as the maximum here. That's why you don't see another tail on the top here. Okay, now we have the range. And so this means that from the maximum to the minimum, there's a range of 5. So it goes from here to here. So there, and again, some of these are a little more awkward to interpret. So if this was like age, it would be easier to say, oh, the range is like from this year to this year. There's a span of 50 years in the ages or something, right? And so this one gets a little more complicated, but that's okay. So here's our template. So among our respondents, there's a difference of 5 between the respondent with the most belief in God and the respondent with the least belief in God, ranging from 1 to 6. So again, that doesn't tell me too much here. So what I'm going to say is that respondent beliefs ranged from atheism to doubtless belief, right? That there were actual responses. So it's not asking what the coding was. What it's telling me is that there's at least one respondent who was here and one respondent who was here. So it spanned that entire like 1, 2, 3, 4, 5 hops from one to the other. Okay. So from my minimum to my maximum. And finally, my interquartile range, right? This is the middle 50%. So the middle half of the data ranges from individuals, let's just say from respondents with 3 to respondents with 6. There's a range of, and so the label, this is like, again, if this was income, you'd do, and it was like 20, you do $20,000, right? That's how you'd add the label on. There's a little bit, this is a little bit different. There's a range of 3 within the middle half of the data from the individual with the least to the individual with the most. So then we're just kind of saying, right, this span here. So let's redo this to make a little more sense. Because again, these 3 and 6 don't really work with what we're looking at. So a 3 is, I don't believe in a personal God, but I do believe in a higher power of some kind. So the middle half of the data ranges from respondents who believe in a higher power, but not a personal God, to respondents with a 6, so who are doubtless in their belief in God. There is a range of 3, so that's saying it's going from 3 to 6, like these hops. I don't think that's that useful for this particular one. I'm just gonna leave the first sentence here. Again, if this was something like age, right, I could say like there's a range of 20 years within the middle half of the data from the individual who's the youngest to the one who's the oldest, right? Or from the 20-year-old to the 50-year-old or whatever it is. Okay, so these are my interpretations. So notice that I'm not just putting the numbers and I'm not just putting values. I'm saying, what does it mean for, right, Q for the IQR to equal 3? It means that for the middle half of the data, right, for the middle half of respondents, they're going from belief in a higher power to definite belief in God. That's where the middle half of folks are. Okay. Next, I'm going to break this down by another variable, a categorical one, something with 2 to 5 potential responses or codes. So I want to think about, what do I want to see if theism varies by? Like, do I want to see if, for example, people of different ages have different beliefs, people of different classes, people with or without a college degree, gender. So I can choose one of these to change it by. And why don't we just use gender for now? So let's see whether it beliefs in God varies by gender in terms of the distribution. So I'm going to choose gender M, and which has 2 different responses, right? This is a nominal level variable. And it says first to make a frequency table and share my syntax and output. So let's look at gender to understand its distribution. So here, problem number 7, I'm changing the variable name to gender M and clicking play. or I can go analyze descriptives frequencies. And as long as display frequency tables is there, then it'll give me the frequency table. I put the variable into here. It's going to give me all this. I could turn this off. I could like uncheck these if I don't want these, but let's just run there. So here's my frequency table. So I want to, again, include both my syntax and my output. And then it says, explain the story of your frequency table. So what I see here is that among the 3,529 respondents for whom I know their gender. So I'm looking at not the missing, but the total right here. We can see that like 1,810 are women and 1,719 are men. Percentages are going to be a little easier to interpret. And then you can also see that we're going to use valid percent and not percent because the percent includes these missing ones that we don't know their gender. So of the people we know their gender, just over half, 51.3% are women, and just under half, 48.7% are men. Okay, so that's all I need to do for that one. And so now I'm going to create side-by-side box plots. So we have a box plot here of theism, right? We can see it broken down into the quartiles, right? If you took all of those respondents and you had them kind of line up from 1 to 6, you'd have, and then you kind of, you'd have a quarter of them between here and here, a quarter here to here, a quarter here to here, and a quarter at here. But now we're going to break this down by gender. So my primary variable was theism. And then my categorical variable name was my gender one. So I can do that. If I do this, it's just also going to break down. It'll show me like both of their medians, both of their means, etc. But for this one, I'm just going to do the box plots. I'm going to click play. Or I can again go analyze, descriptive statistics, explore. And here I have theism. And then I'm going to put into the factor list. I did gender, but let's say, for example, I wanted to do political party. And as long as I have plots on, it'll give me the box plots. If I have both, it'll give me that and that. So you can see this one, right, is showing me the difference among parties. And you can see actually independents and Democrats look very similar, but Republicans, actually folks having less belief in God, they're outliers among Republicans. Republicans are centered them up here. Let's go to gender. So here's my gender one. So I want to take my syntax. And I want to take my output. Okay, and then it says compare and contrast the distribution using real life contrast. So for theism, again, going 1 to 6, we can see that the maximum's the same, right? The minimum's the same, but we can see that this box and the median are in different places. So here, actually, we can see that for women, the median is at 6. Half of women, at least half of women are at 6 or higher, right? And then the other half are at 6 or lower. So you can see that, well, at least half of women have, again, 6 is the like definitely believe have certainty that God exists. We can see that half of men are between, well, we can say at least half of the, so like the most theistic, half of men are between a 5 and the 6. So between doubts and certainty in their beliefs. We can also see the middle half here is between 4 and 6, and the middle half here is between 3 and 6, right? This skew 1 is lower. So a quarter of men are between like 1 and 3, whereas a quarter of women are between 1 and 4, and then the next quarter are 4 to 6, and here the next quarter are like 3 to 5. So we can also see that this distribution is a little bit lower, right? So there are also more men who are less theistic compared to women. Okay, so we can just see right here that, right, these distributions in some ways look similar, but that men, it's kind of shifted down a little bit where there's more men, the least theistic quarter of men are at a 3 or lower versus a 4 or lower. So this was higher power, but not a personal God. And then this is agnostic. Sorry, no. 2 is agnostic. 3 is higher power, no God. 4 is maybe sometimes. So for women, the least theistic quarter are between atheist and sometimes, whereas for men, it's between atheist and higher power, but not believing in God, right? Okay, so I think that's good. Again, if I were to look at a different one like this, I'm going to compare them, and I'd say, for example, again, that while the least theistic quarter of Democrats and independents are between atheist and believing in a higher power, but not a personal God, all of those cases for Republicans are outliers. They're extreme cases. And for Republicans, right, the middle half of Republicans are all between a 5 and a 6, right, between doubts but believing and definitely believing. Whereas for Democrats and independents, we can see that that's the top half, but not the middle half, right? The middle half is between a 3 and a 6. And so we can see there's a whole quarter here that actually is below the middle half for Republicans. So I'm just having you compare whatever that primary variable is among your categorical variable. Okay, so finally, I should show you that. So finally, I'm just making sure I have everything here. On the actual independent lab, you're going to add your name, and there's also a question about what kind of feedback you want at the top. And I'm going to save it, and then I'm going to go and attach this Word document and submit it. And so again, for your demo lab, you're not submitting anything, you're just working on this. But then for your independent lab, you're going to submit your work using the other data set, and the feeling smarter variable you will get assigned based upon the survey.